dun, dun, dun. Yeah, you got it. The next one we're going to call multiplication. So this multiplication is actually counting many additions. So the whole idea of multiplication is that we count a bunch of additions hidden inside. Let's take a look at what this actually plays out like in practice. Let's pretend that we had 3 times the number, I don't know, let's say 7. Well, 3 times 7 means that I'm going to have 7 units 3 times, or I'm going to add 7 to itself thrice. Oh, sugar. You like that? You like that use of the word thrice? Oh, yeah. Hella old school. All right, so the whole concept here is when I go 3 times 7, it means I take 7 plus 7 plus 7. And of course, if we remember back to our addition tables, or excuse me, multiplication tables, we would call this 21. We could also draw the diagrams associated with this. Here I have my first 7, second 7, third 7, and now I want to know how many total units do I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 units. So multiplication counts the number of additions that I'm doing. Division is what I want to call the inverse operation of multiplication. There's kind of 2 different ways to write divisions, by the way. We have this, what we call division sign, that little thing. And I say that 10 divided by 2 is indeed 5. Another way to say this is using the division line, or the division, like little, there's a formal name for that. I kind of forget it at this moment. 10 divided by 2 equals 5. So this one is 10 divided by 2 equals 5. 10 divided by 2 equals 5. I want to give some names to these things. Here, the one on top, we're going to call the numerator. And the one on the bottom, we're going to call the denominator. And then the one over here, we're going to call the quotient. So the output of a division is a quotient. If we take this concept and map it over to this sign, we would say the one on top, in this case 10, we're going to call the numerator. The one on the bottom, we're going to call the denominator. I always wanted to see Arnold Schwarzenegger in a movie called The Denominator, where he's just under everything and trying to get out. Quotient. All right, so 10 divided by 2 equals 5. That's how we read that. Let's take a look at another example of division. What if we were to try to undo multiplication here? In other words, we were to say, all right, I would like to take 21 units and chop them up into three equal size pieces. Okay, so here's a total of 21 units. If I chop them up into 3 groups of equal size, how big is each group? Well, we see that each group is of size 7. If we write that in this notation, we say 21 divided by 3 is equal to 7. So again, we have the thing on the bottom is going to be called the denominator, the thing on the top is the numerator, and the thing on the other side is the quotient. I want to call your attention and show you exactly what I'm talking about. If we said the general format was numerator divided by denominator is equal to quotient, kind of see how I set myself up. In other words, numerator divided by denominator is equal to quotient. The whole idea that division undoes multiplication really comes in right here. If I were to look at bringing the d over to the other side, so I multiply both sides by d, this statement is true if and only if the numerator is the quotient times the denominator. And we see that actually playing out here. When we say 21 divided by 3 is equal to 7, the reason that that's true is that 21 is 7 times 3. In other words, if I want to undo a group of size 21 and break it into 3 different slices, each of the same size, I must have 7 items in each slice. Same thing over here. If I want to take a group of size 10, break it into 2 pieces, each of which has the same size, well, it must be that each of those pieces has 5 items in it. So in other words, when we're looking to break up a number and divide it by another number to get the quotient, what we're really saying is, what do I have to multiply the denominator by to get the numerator? And that's why this is the inverse of multiplication. In the next video, we're going to take a look at some more rare operations. These ones are super famous. We're going to see some stuff that's been hiding in the shadows for a while. I'll see you in the next video.